So this pencast is on literal equations, and literal is related to literature. It means letters, and so there's going to be multiple variables in these equations, and so we're always going to have to solve for the indicated variable. We're not going to get a numerical solution in these cases, so they're always going to have to tell us solve for x or solve for z or f or g, whatever letter they want us to solve for. In example A, it says f equals 9/5 times c plus 32 for c. So they want us to solve this for c, which means get c all by itself on one side of the equation. So the first thing we're going to do is subtract 32 from both sides. That gives us f minus 32 equals 9/5 c. I know now that c, the term with the c in it, is all by itself on one side of the equation, but it's being multiplied by 9/5. So to get rid of that fraction, I can multiply by its reciprocal. So I am now going to multiply both sides of this equation by 5/9. If we look here, 5's cancel on this diagonal, the 9's cancel on this diagonal. So I just have c left here, and then we've got 5/9 times f minus 32. And since all we were asked to do was solve for c, there's no sense in distributing that 5/9. It's not going to do us any good. One thing we do want to do, though, with our final answer is write the c on the left-hand side. So we're going to rewrite this as c equals 5/9 times f minus 32. Now we have an equation to solve for c. In example B, we've got v equals v naught, and that little 0 down in the corner is read as naught. So v equals v naught plus a times t. And they want us to solve this for a. So first I locate a, and I can see that the v naught term needs to be moved over to the left-hand side. So I'm going to subtract v naught from both sides. Now remember, these are not like terms. V and v naught are totally different terms, so I can't subtract them because they're not like terms. So I'm just going to write v minus v naught equals at, because those canceled. Now I want to solve this for a. So if I look here, the a is right now being multiplied by t. So to get rid of it, I have to divide by t. Here the t's cancel, and I have v minus v naught divided by t equals a. And then once again, in my last step, I'm going to switch sides of the equation and write a equals v minus v naught divided by t. In example C, we have w equals p times v sub 2 minus v sub 1. And the sub 2 and sub 1 are just distinguishing those as separate variables. You see that quite a bit in physics. And we want to solve this for v sub 2. So the first thing I'm going to have to do is get rid of this multiplier of p. So that means I'm going to have to divide both sides of my equation by p. So these p's cancel, and I have w over p equals v2 minus v1. I can drop the parentheses because there's no multiplier on the outside anymore. Now I was asked to solve for v2, which means I need to get rid of v1. If I do my addition of the opposite, I see I have a negative v1. So what I need to do is add the opposite. So I'll add v1 to both sides. So that gives me w over p plus v1 equals v2. And v2 is now all by itself. I just have to switch sides of the equation. So I've got v2 equals w divided by p plus v1. Alright, So the other sort of literal equations that we're going to work with, and we're actually going to work with these much more in Math 097, is it says express each equation in the form y equals mx plus b. And later on we're going to talk about the fact that this is something called slope-intercept form. It's going to be very important later on. So we want to make sure that we can basically, what this is asking us to do is to solve the equation for y. We want y all by itself. Then we want the x term in front so that m is going to be a number. So we're going to give some number x like 4x or negative 7x. And then we want the constant term last. And so that b term will always be a number. So in example D it says x plus y equals negative 4. Well, in order to get this solved for y, to get y by itself, we need to subtract x from both sides. Now notice that I'm writing that x in front as if it were a negative because I want the x in front. So x minus x cancels and I've got y equals negative x minus 4. In example E, I have 3x minus 3y equals 6. So first thing, I'll change my subtraction to addition of the opposite. Now I need to get the x term over on the right-hand side, so I subtract 3x, and then once again I'm going to write it as a negative in the front. So that cancels, and I have negative 3y equals negative 3x plus 6. Now I have negative 3y, and I want the y to be all by itself. So negative 3y means negative 3 times y. So I have to divide each term in my equation. All the terms have to be divided by negative 3. So negative 3 divided by negative 3 is 1, so that cancels. And I have y equals negative 3 divided by negative 3, once again, is 1, so that cancels. And I have x plus 6 divided by negative 3 is negative 2. Now, in a final answer, we don't want to leave this as plus negative. What we're going to do is adding a negative is the same thing as subtracting. And so we're going to use a single symbol of subtraction to represent that. So we're going to write this as y equals x minus 2. Basically, we're undoing that rule that says subtraction is addition of the opposite sign. Just makes the answer look a little cleaner. In example F, we have 9x plus 4/3 y equals 5. So we know the x term needs to go on the right-hand side, so we subtract 9x on both sides. Now we have 4/3 y equals negative 9x plus 5. Well, we've got 4/3 y. So in order to get rid of that multiplication of 4/3, we can multiply by the reciprocal. So we're going to multiply each of these terms by 3 over 4. And we can put that over 1 so that we can see what we're doing. So once again, here the 3's cancel and the 4's cancel. That gives us y equals, now here we've got 3 times negative 9 is negative 27, 4 times 1 is 4, and we have our x, plus 5 times 3 is 15, and 1 times 4 is 4. When we have fractions in our answer like this, we want to make sure that the fractions are reduced. But 27 over 4 is not reducible, and 15 over 4 is not reducible either. So that is our final answer. Y equals negative 27 over 4x plus 15 over 4. Our last example, example G, we've got negative x plus 2/3 y equals 0. Well, we want to get the x over on the right-hand side, so we add the opposite, so add a positive x. And that gives us 2/3 y equals, now I could write x plus 0, but x plus 0 is just x. So I'm going to write x. And then to get rid of this multiplication of 2/3, once again I'm going to multiply by the reciprocal. So the 3's cancel, the 2's cancel, and I have y equals 3 halves x.